Hello, my name is Mads Jespersen. I'm from FlowHow. In this small video, I want to show you how to use copy paste if you want to match a mold insert to a part, or also if it has a mold part to a part insert. But I'll just show it on a mold insert. So you can use the normal try to use non-matching, but you can also use a matching mesh. You can turn it off and on under the meshing control solid here. To be 100% to be in control of the meshing, it's sometimes a good idea using matching mesh. I have prepared a bit on a part like this, and if you want to do a copy paste, you can of course just mesh it, um, keep the core here. I have trimmed it off here just 1 millimeter below the part because I want to copy the mesh from inside here and combine it with this. Um, and I will also show you how that we combine the water channel. I made the water as a solid because it's much easier than using lines and give them a attribute of cooling channel, because then you have to um, yeah mess a bit around in the mesh sequence. But this is the easiest way to do this. So back here, I'll import the model, a part, a gate, a core trimmed, a cooling channel, and a mold base. I've also made the mold base. It's just a box in the CAD system and exported as a step file. Mold insert, mold base. I'll just hide the mold base. I don't like to see that part. Cooling channel. And you can see in my program, Rhino, which is my CAD program, it's a surface meshing. So I have an open surface here. If you have a solid, you would have it closed here. You just have to delete it. But the easy thing about having it 1 millimeter or half a millimeter away from the part is that it's easier to sew together at the end. So this is the mold insert. Mold insert. Where are you? Yeah. And I normally specify the mold insert, so I give it a core. I'll just write core like this. So now, oops, forgot this one. This is also, of course, you can use this, but I just made this one. And melt entrance, and I need inlet outlet on the cooling. Of course, these cooling channels are trimmed exactly to the mold base. That's also why I'm using the mold base there, or exported the mold base from the CAD system. So now we just have to give it some seating or some mesh. Um, I'll give it. It's quite important that you keep nearly the same seating in the regions where you want mesh matching. So I give this one seating 1. I'll just give it a 1. Apply. Okay. Okay. And then this one down here, I'll give 2 because I don't want that fine and so many elements. But I also give this one a 2 millimeter mesh. So I'll take those both at the same time, 2 millimeters. Apply, okay, okay. So now we have the seating, and then I want to generate. I'll stop the sequence here of meshing by clicking, putting in the pin, generate. And now you can see these are not matching. So what my job is now is to first match this down here and sew it together, and then afterwards this one up. So away with the part, I'll just have focus on the cooling. I'll use the inner surface from the mold, from the here you can see this is not matching. So what I'll start with is go to fix mesh. We have some free edges, we know that, but I'll delete. Don't want to see the core. What select surface meshes? These two. Yeah. Okay. And then I'll delete some elements. I'll look from the side, and I'll take these. Say away with this. And then I'll just turn on the core to see if there's a gap between. Yeah. This one looks good. This over here, I need just to delete a bit more. And take these like this. So now we have an open cooling channel. So I'll use the inner mesh from the core, copy that over to this one and sew that together. So I'll do copy paste, hit this one. You can see it's split in two, so I'll keep shift down and also take this one, say okay to that, and then it asks which of these elements I take all and which do I want to assign it to. I want to assign it to the cooling channel. Okay, and away with the core. And now this mesh now belongs both to the core, but now I copy it over so it also belongs exact the same. And of course I can't move the nodes now or the mesh here. So what I do is I'll see if I can use this fill annular, this one, yeah, and it closes it. Fill annular, this one, yes, combine to this one. It did not a good job here. I'll say undo. So what I can do is I can sketch. I'll sketch, take this one off and say mesh, this, and this, like this. And now I have this one, I can fill the hole instead of using this annular. This annular doesn't work all the time. So I use this one and then I mesh it between this point and this point. I take it in small portions, this point and this point, and this point and this point, and hit enter, then it closes the gap. Okay, look here, it also did some nasty shit. So I'll just delete it. So I'll sketch again. This, enter, and then I'll fill it. Because now I have one closed loop, like this, and maybe I add enter. So now I have it as I wanted. Exit. I'll just save. And now these are matching. If I look at this one, I don't have any non-matching. So the next step is to use the inner surface from the part and then sew it together the same way. So what I do now is I'll only show the core, and then I have to copy paste the inner here. I can of course point it out single by single, but I normally use this neighbor, select neighbor surface mesh. So I just pick on the one that's farthest away from the part, and when I hit neighbor, all the neighbors to this mesh will be highlighted too, like this. And these are exactly the parts or the mesh that I want to copy. Copy paste. I mark these elements, all elements, say OK, select the one object you want to assign it to. I have hidden it, but I'll just make it visible and click on this one, say OK. So if I hide the part again, now I have exact the same issue as before. I'll just see if I can make the fill annular. Maybe it works, maybe it doesn't work. I think it has a, yeah. I'll just check around. Yes, it closes the gap, and now I have a totally fully non-matching mold insert. So the next step for me, give it a save, is just go ahead, generate. So now you can see match contact faces, and yeah, I just generate. Oh, now I put in the pin. I put in some solid mesh, and then I generate the rest: the cooling channel, the mold insert, and the mold base. Final check. Like this. And then I go to the project tree, as I call it, give it a material, process, I just use some of my settings, 0.8 maybe, no profiling of the filling, packing time, refers to machine pressure, so you are in control of it. I'll give it 350 bar, 35 megapascal. Go here. Always change this to transient. If you want to see the effect of, for example, having the core in MoldMax, initial mold temperature, back, I've got cooling time 5 seconds, opening time 3 seconds, cooling channel, and give in the water here, mold metal, and here I have the mold insert. I'll change this for mold max. Next, finish, okay, and then I'll run an analysis. Double click here, go down to transient analysis. My computation about the cooling is 9 time steps, and also here, it's like this. So now I'm actually ready to run the analysis. Of course, I want normally to compare the effect of having a core in MoldMax or Amco or something else. So I need also a mesh or a model where this core is steel. So the normal thing I just do is I say copy run, right click here, copy run here, and then I double click the process, go into cooling settings, mold material, and I just changed this for steel. Could be any steel, but I used the P20 as a normal general tool steel. Okay, save, okay, close. And now I'm actually ready to run 5 and 6 and see the effect of changing this mold core from steel to mold max. And you can see I have done some already. So if we look at the results here, I can see cooling, and then I take a time step because I had the transient cool. Then I have some time step and say 7.84 seconds. What is the temperature? This is with mold max core. You can see this inner core is actually colder than the general big core because of the heat conductivity of mold max. And if you then want to compare to the steel core, you can do it here. I ran also this, and you can see now this out is the same temperature. It's around 40 degrees, but inside it's around 90 degrees, and this is even not at the time where it was the end of cool. Okay, it doesn't change that much, but you can see I use Moldex3D to take the decision if it makes sense uh, to change a core from steel to mold max, for example. And instead of and simulation, it's great because you can just run a simulation and find out, does it make sense to use a lot of money uh, changing these cores around in the mold. Okay, that's it for now. Thanks for listening. Bye bye.